Hello, everybody. Welcome to your topic 3 ticket to retake. I'm just going to go through these review problems to help you guys prepare for retaking your test. All right, so first we are talking about identifying domain and range of different relations and then determining if the relation is a function. Explain how you know. So just a couple reminders about domain and range. So domain is the input and also the x values. Range is our output, and the output is the y values. All right, so first we're going to identify the domain and range for number 1. We have this lovely graph here. I notice it's just made up of ordered pairs or points on the graph. So the ordered pairs is what we're going to focus on to find the domain and the range. I'm realizing I don't have a ton of space here, so I might steal some of the space over here. All right, so the domain is going to be the input of our relation, which will be the x values of these ordered pairs. So I'm just going to work left to right on the graph. If I come in from the left, we've got this ordered pair. The x value here is a -4. Actually, I can zoom in here for you guys. Oh, look at that. Okay. Uh, These points right here both have an x value of -2. So we've got a -2 in our domain. And even though the -2, we see a couple of them, you only need to write it once when you are listing your domain. This ordered pair right here is a -1 for the domain. Again, I'm just looking at the x values. And then over here, these points both have a 3 for the x value. So there's our domain. Range is going to be the y values for each of these ordered pairs. I'll work bottom to top. When I go bottom to top, I'm going least to greatest. It just orders my numbers quite nicely. When I did the domain, I went left to right to get the numbers in order that way. But all right, so our range, these points down here have a y value of -2. Next, we have this one, which has a y value of 0. These points right here have a y value of 1. And then last, we have this one right here. Oops, right here. It has a y value of 2. Okay, so there's our domain. Um, we've identified domain and range, and the question is this relation a function? Explain how you know. So when you guys are looking at a graph like this, there's a visual check you can do to see if you have a function. It's what we call our vertical line test. So if you can picture a vertical line, I'll try to draw one in here for you. Oftentimes, using your pencil is a good way to tell, or good vertical line to use. So there's my vertical line. And what we want to look at is to see if we were to take a vertical line and move it across our graph, does it ever cross through more than one point at a time? I'm noticing my line is not super straight, but right here, do you see how the vertical line is crossing through those 2 points together? And then over here, we're crossing through these 2 points together. So that means that this relation is not passing the vertical line test, and that would mean that it is not a function. What we have going on with that, what we're noticing with a vertical line is if I were to write out the ordered pairs, these ordered pairs would have the same x value, so that would be a repeating x value. The input of -2 has an output of a 1 for that ordered pair and an output of a 2 there. And that's not how a function works. All right, so moving on to number 2. I guess I didn't need that space that I was trying to take for the last problem. Here's a relation. It's represented with a bunch of ordered pairs. So is this a function? Actually, no. First, what's the domain? What's the range? So domain is your input. Domain are your x values. So we're just going to look at each x value. We have a 1, 5, 7, 2, 8, 3, 5. So 1, 5, 7, 2, 8, 3. And then the 5 we already have right here, so we don't need to write it again. Our range is our output, which is all of our y values. So that's an 8, 3, 6, 2, 4, 9, 7. So is this relation a function? When you're looking at your ordered pairs, you want to look at your x values. Do you have any x values that repeat? That's kind of a quick thing you can look for. And we notice that we have a 5 right here and another 5 right there. So what's happening is we are inputting a 5 and our output is a 3. And then if we input a 5 and our output is something different, a 7, that's not how functions work. That is not a function. And then to explain how you know, you could say that the x values repeat. You could say one input has two different outputs. That's not a function. All right, so number 3. Maya is tracking the amount of rainfall during the storm. Describe the domain and range for this situation. Include continuous or discrete in your description. All right, so for these real life examples, when we have to determine a domain and range, the way that I like to think about it is, domain is your input, it's your x values. Range is your output, it's your y values. Your input will determine the output. The x will determine the y. The domain will determine the range. So if we think about what's happening in this situation, I want to know what is determining the other thing. And that just helps me clarify between domain and range. So Maya's tracking the amount of rainfall during a storm, and she's doing this over time. So we have time, and then what is she tracking? She's tracking the amount of rainfall. So here's the question. Does the amount of time determine the amount of rain that has fallen, or does the amount of rain that has fallen determine the time? Like number of hours, number of minutes, whatever the time may be. And when we think about it in that way, we would say, well, the amount of time would determine how much rain has fallen. So that means that the time is our domain, and the amount of rainfall will be our range. All right, is this a continuous or discrete situation? Up here, where you have these separate points, this is what discrete looks like. Some examples of things that would be discrete, let's say I was buying pencils. I could buy one pencil, two pencils, three pencils, four pencils. I That is what discrete looks like. I cannot buy 1.1 pencils 1.15 pencils, 1.78 pencils. Um, Continuous is when it's okay to include everything in between. So, like if I'm looking at between a 1 and a 2, if everything in between the 1 and the 2 is reasonable for the situation, we would call it continuous. So, if we think about time, um, let's just say between 1 minute and 2 minutes, can we include all the time in between there? Or can I only look at 1 minute and do I have to jump to 2 minutes? Well, you could measure how much rain has fallen after 1.5 minutes, 1 and 3/4 minutes. So everything in between there would be okay. And then how about the amount of rainfall? Rainfall can be measured in, I don't know, let's say inches, centimeters, whatever you want. Does it have to be 1 inch, 2 inch, 3 inch? That would be discrete. Or can it be measured in some values in between those? And if it's okay to be measured in all the in between stuff, then we would call that a continuous function. All right. So number 4, if f of x equals 4x minus 3, evaluate the following. So as you guys are first introduced to function notation, it looks a little bit confusing. This f and 2, it almost looks like f is a variable that I'm multiplying by a 2, but that's not what this is. This is just a notation. Think of it like a labeling system. The way that we would read this is f of 2. What that tells people is we want everyone to go to your f function and plug a 2 in for the variable. That's all it is. It's telling us what function to use and what to substitute in for your variable. So we're going to go to the f function and we're going to substitute a 2 in for the variable. Here's our f function, f of x equals, the function is 4x minus 3. This 2 is going to get substituted in for that x. So we're going to do 4 times 2 minus 3. 4 times 2 is 8. 8 minus 3 gives us 5. So f of 2, we're evaluating the function when x is a 2, equals 5. All right, next one, same idea, f of 6. We're going to go to our f function and plug in a -6 for the variable. So we're going to do 4 times -6 minus 3. 4 times -6 is -24. Carry down the minus 3. And -24 minus 3 is -27. So f of -6, again, just a label, equals -27. All right, number 5. Given that f of x equals 4x plus 1, describe how the graph of g compares with the graph of f. Okay, so I think highlighting can I'm going to use a highlighter, can kind of help us to see how a graph changes. So if our original function is 4x plus 1, I'm going to highlight it. And then we get to g of x and we're making a change to the 4x plus 1. But why don't we try to find the 4x plus 1 within our g function? So I'm going to highlight, here's 4x plus 1 right there. I'm just going to highlight that. What that does is it just helps me see, oh, this is the change right here. This is the thing that's different. If you're making a change to the entire function, so here's the entire function, and we're making a change to the whole thing, that's going to be a vertical change. And if you're making a change with addition or subtraction, that change is going to be a translation. We can go up or down. If it says plus 3, that means we're going to go up 3. So this is a vertical translation, up 3 units. All right, let's take a look at g of x. So g of x equals 4 times x plus 3 plus 1. And if we remember, our original function is the 4x plus 1. So if I come over here, I'm going to highlight the 4x plus 1, or I'm going to try to find it. Me highlighting it is just me finding it. I can see the plus 1 on the end. That's from the original function. Here's the 4. And then what that's just showing me is the change is there's a plus 3 in here with the x. So that's the new thing right there. That's what was not in the original function. So if you are making a change to just the x versus to the whole thing, over here, the change was the plus 3 to the whole function. Here's the whole function plus 3. That's a vertical change. If you're making a change to just the x, that's a horizontal change. And then that horizontal change, because the change is with addition or subtraction, it's going to be a horizontal translation. And then this is the one that's a little bit tricky. If you guys have me in class, we call this our tricky x. If it says x plus 3, our instinct is to want to go to the right, to where the positives are. But we have to do the opposite of that. If it says x plus 3, we go to the left 3 units. All right. Number 6, given that f of x equals x plus 2, describe how setting k equal to 4 affects the slope and y-intercept of the graph of g compared to the graph of f. Okay, so I'm going to talk about a couple things here. Again, our original function, I'm just going to highlight, the original function is x plus 2. If we look at part A, we want to see where's the function. Here's the original function x plus 2. I can see that we are multiplying it by a 4. If you multiply the entire function by something, or if the change you're making is to the whole function, that's a vertical change. And then when that change is with multiplication, so up here, the change we made was with addition. Now the change is with multiplication. If we're going to multiply the entire function by something, this is going to be a stretch or a compression. For vertical stretches and compression, if what you're multiplying by is greater than 1, this is going to be a stretch. So this is a vertical stretch by a factor of 4. So the question is, how does this affect the slope and the y-intercept? Well, if we are multiplying the entire function, the original slope and y-intercept by 4, then both the slope and the y-intercept get multiplied by 4. So we would say that both the slope and the y-intercept change by a factor of 4. All right, so g of x equals 4x plus 2. Let's try to find the original function. Remember, the original function is this x plus 2. So I can see that here is the plus 2, and then there's the x right there. And our change that we're making is this 4. In this example, we are multiplying just the x by a 4, not the whole function by a 4 like we had here, just the x by a 4. So if the change we're making is to just the x, that's a horizontal change. And then if that changes with multiplication, it's going to be a horizontal stretch or compression. And here's where it gets a little bit tricky. I can see that we are multiplying by a number by 4, which is bigger than 1. Over here, when it was a vertical change, If we're multiplying by a number bigger than 4, it's a vertical stretch. Well, the horizontal is going to be the opposite of that. Um, if we multiply by a number bigger than 4 and it's a horizontal change, this is going to be a horizontal compression. And then the follow-up question is, how does it affect the slope and the y-intercept? Well, the original slope, was just a 1x. And then here's our x, and I can see that if we're multiplying 4 times the x, that's going to change your slope. This will turn into a 4x. But do you notice how the y-intercept does not change? It's going to stay as a plus 2. So there's no change there. So only the y-intercept changes. Excuse me, only the slope changes by a factor of 4. All right, number 7. The minimum wage for employees of a company is modeled by the function f of x equals 7.25x. The company decided to offer a signing bonus of $75. How does adding this amount affect the graph of an employee's earnings? All right, so if we look at our function, f of x equals 7.25x, they did not tell us a ton of information. I am going to speculate that x is representing the number of hours worked, and the 7.25 would be that hourly rate wage. So we take the number of hours worked multiplied by 7.25. Now, the company is trying to hire some people. Hey, come work for us. So they're offering a signing bonus of $75. What that means that in addition to paying this hourly wage, they're going to add on a $75 signing bonus. So if we think about the original function was 7.25x, here's the original function, and see how the change we're making is we're adding $75 on. So if we're making a change to the entire function, that is a vertical change. And if we're making the change with addition or subtraction, it's a translation. So our vertical translation, when it says plus 75, that means it's going to go up 75 units.